Going live. We should be live. Hello, hello. As you're joining in, always say hello in the chat. Makes it definitely way more fun for me. Hopefully more fun for you as well. And we're a couple minutes early, so we'll wait a couple minutes before we really get going into any of the content today. But if anyone is already here, say hello. It's always good to double check you can hear me. It looks like my mic is on, but always good to double check you can hear everything as well. And I will share this probably a couple times again because we're a little early here. I'll share it again as more people join in. The code and event links and everything for the stuff that we talked about today, but also all the stuff that we've previously talked about, which is quite a bit now. We've done not every week, but almost every week we've done a stream on Fridays. We've had to skip a few in the summer from some sometimes work travel, but also just personal travel. So I try to do this almost every Friday. And if you're new here, we pick a topic. And then the idea is, well, at least I spend at least an hour, if not more, a week trying to learn and build something on that topic. I usually spend way more than that. This week, I didn't get to spend as much time as I wanted. And then usually we've had some other people come in as well and share their projects. So if you have a topic or a tool that you think sounds really interesting and you want to check it out, this is kind of a cool place to do that and acts as a forcing function to like go and do that before the stream date. So usually, like I mentioned, we've had other people come up, share the project throughout that they built throughout the week as well, which has been really fun. And a lot of times they kind of build on top of each other. So we're actually here. I did not update the main README. We just did open source music generation last week. The week before that, we did open source text to speech models. And then we kind of had this whole generative media AI arc going on because then before that, we had open source video generation and open source image generation. So it's been fun kind of picking kind of like a little bit of a topic that can tie together. And this week we are doing or talking about reinforcement learning in MuJoCo. MuJoCo is a physical simulation environment. I'll show more on that here in a second, but allows you to do runs where you can, this is actually training right now, but it gives you an environment and you can bring models into the environment. There's pre-existing ones. So this is a pre-existing model of a Unitree G1, which is a real life robot. So in theory, if I had one, which I do not actually have physically one of the G1 robots, although I'd love one, I could train a model in here. And then when it gets good at walking on, let's say this is kind of a rough train, I could take this trained model and bring that into the physical unit. And then it could be pretty good at walking, hopefully, on whatever train it's trained in. You can bring in other sensor data and stuff like that as well. So I have a run going right now, running. I just think the falling down is really funny. This is running in a MuJoCo environment. Well, again, we'll talk more about it, what that looks like. But you can see this is the reward. So usually in reinforcement learning, you have a reward. And the reward for stuff like this can be pretty complex. Like there can be kind of 29 or plus, I think, in this one with all these different joints and stuff. Like you get the basic way of thinking about it, though, is you optimize an algorithm to get a better reward. And that reward could start out with something as simple as like moving forward increases the reward. But then with things like walking, you actually have to add stuff in that not just moving forward does, but like staying upright or moving your arms a little bit or creating like a correct walking gait or moving your feet and having air time with the feet, because otherwise it'll do weird things like shuffle or throw itself forward, and that increases the reward. So there's a whole thing of reward shaping, reward hacking that makes robots do things that you want to do. Otherwise, they can just increase that reward by doing weird things. So if you said move forward, but you didn't give it any air time for the feet, for example, like it could just shuffle, never lift up its feet, and it looks really weird, and it's not really the walking that you want it to do. Or it could like crawl on the ground, right? So there's all these things you have to think about when you start bringing more complex things into like a physical environment about how to shape that reward. But there's much simpler models that you can also run in MuJoCo out of the box that is a little bit easier to build. And somebody said, "Hey, Sage, great event yesterday." Oh yeah, thank you for coming out, Jimmy. It was awesome to see you there. We did a hack night last night in our office. It was really fun. And we're probably going to do more of those. So if you're in Seattle, keep an eye out too. We'll probably do another one next month. It's kind of fun. Actually, kind of some people have told me they want to do stuff kind of like this stream, but in real life. So there's like a topic, and then the goal, do presentation on the topic or have like an expert in that, and then bring him into the office. They do a presentation, and then you have open time to kind of build on the topic. So, and if you're new here, again, I see a whole bunch of people joined in. So this is the AI Build and Learn, which is a stream that I've been doing almost every Friday since I think late March or something like that. And we pick a new topic every week, almost every week, like I was saying, and then learn by building something together. Again, I try to at least spend an hour on the topic. Often it's way more. Sometimes I don't have as much time during the week as I wanted. And you can also talk about what you're building like throughout the week if you don't want to wait for the stream. In the Slack channel, there's a ML and AI Slack channel in the Slack group. That's kind of where the discussion happens. I usually share too like a thread about what I'm building in there, so you can check that out. And again, the topic this week is this reinforcement learning with MuJoCo. Before we go into it, does anyone have ideas for next topics that you would like to cover? I'm thinking we're probably going to go back into the agentic space after we have the next like 4 booked. But I'm curious, like, does anyone have specific tools or things they've heard about? It could be a kind of an overall topic. It could be a specific tool. It's been fun when it is a specific tool, but it can go towards a topic. For example, like evals, but you have a tool in mind that you've heard about that's good for evals. We've done that in previous ones. The next one's coming up real quick. I'll go over that, and then we hop into the topic more today. As you're thinking of what the next topic should be, though, so definitely let me know in the chat. Somebody has to have some ideas of what they want to learn. So again, reinforcement learning MuJoCo, the physical simulation environment. You kind of saw what it looks like. We'll go more into that. And then next week is kind of building on this, is a very similar topic, but is using NVIDIA Isaac Sim. So that's kind of a more advanced, I believe, from what I've seen, like simulation environment. And then the point of why we're kind of actually doing these is I wanted to do stuff with world models. So we'll be checking out world models next, but you often need an environment for them to run in. So then we're going to start looking at world models with Dreamer v3. I don't know if this is the first one, but it was one of the earlier ones a few years ago that they like to call a world model. And the world model, instead of just predicting tokens like a LM, you're kind of trying to predict state and the physical simulation that goes along with that state. So sometimes people also say that like video generation models could maybe be a form of world model because they're trying to predict like what would happen and the physics of what would happen in there. But in this case, the Dreamer 3 can actually run like a simulated robot like we're going to do today, MuJoCo, but with its specific model. So it can learn how to walk or interact with environments. And then NVIDIA has their own world model kind of umbrella too called Cosmos. So we'll be checking that out the week after. And then you might have heard about JEPA. This is kind of the type of model that Jan LeCun at least was talking about like a year ago or whatever, that he had more, like he thinks this type of model is going to be more interesting long-term as opposed to just large language models for things like creating, AGI or, a more advanced AI potentially. It's a little bit different than an LM. So we'll be taking a look at world models next, and then let me know what you want to do after that. It'll be fun. Ragus. So Ragus for eval, we actually already did that here. I'll share a link for that, and then I'll jump into the code for this week. But yeah, we were talking about Ragus last night a little bit at the event. It is a really cool framework for evaluation metrics, and not just for RAG anymore, about just other stuff with agents. So check it out if you're interested in that space. But we already did it on the stream here. So maybe we'll do that as an in-person one. But yeah, let me know what you want to do for the next online stream after world models. So I'll share this link one more time too, because a lot more people came in. So again, everything is kind of stored here, including the code that I've done for the week. This week, I definitely did just a lot of kind of side Claude coding to get up MuJoCo running. And then often I'll take these projects that I've done at this like kind of good starting point and then build on them at work and stuff over time. So it's been actually really valuable for me to kind of even just spend a little bit of time of getting projects up and going in these environments and stuff. And then I kind of take what I learned and polish them up over time for some other project. So totally recommend it if you're interested in these topics. Spend an hour. If you be an hour with Claude, hour with the Codex, you can get a lot done in that hour. So again, the topic was reinforcement learning with MuJoCo, or really specifically, we're looking at MuJoCo. MuJoCo, I will share a link out to their official site. The site doesn't have a ton on it, but it has links to the docs and to the GitHub, which is pretty important. The GitHub has a lot of collab as well. So if you want to actually just run examples even as we're talking about it right now, you can go ahead and do that. I have a couple up that we might go look at here in a second. That's kind of an intro to the actual MuJoCo code here. So you're welcome to do that. Go poke around at those links. And this is, again, the project I have. Let's see if it's actually trained a little bit more. So this is using, again, a Unitree, a G1 model. And we'll look at like the intro to MuJoCo collab shows kind of like how you build this step by step, like how do you bring in environments and stuff. Let's see if this actually progressed since we were talking. It's walking a little bit now, right? Like you saw, it was falling very quickly. It's learning a little bit of shuffling. And then I did a run earlier the other week, or earlier in the week, and this is my run where it actually got to be walking pretty well here. And I did 3 million steps. So basically with reinforcement learning, in this case, like if you're not really familiar with it, is usually, like in this case, you have a model. You can do reinforcement learning for LM generation and stuff too. That's really popular right now for LM fine tuning. Like you might have heard of GRPO. The idea is that you have it do an action. In this case, it's this physical model doing an action. And then again, if you were here at the beginning, I talked about reward policy. This has a reward policy of a whole bunch of different things, like not only moving forward increases the reward, but moving its legs in a certain way, having air time for the feet that increases the rewards. So basically, you often start out having it move kind of at random and then figuring out how to increase that reward over time. So eventually you get to, if you have a good reward design, robot walking like this. One note that I was going to mention is because I was playing with MuJoCo several months ago for a different project, and I was trying to do this all on a CPU. So you can do the reinforcement learning, you can run it on a CPU, even if you don't have a crazy GPU. But it was taking forever, and I couldn't do as many steps I think as I needed for the humanoid. You can train one of the more simpler models really quickly with like not a powerful CPU, but I think doing the humanoid one required a lot more steps just because it's much more complicated. It has to balance, has to move right. But they have like 4-legged walkers and stuff like that you can train pretty quickly. So don't feel like you need a giant CPU or a GPU to do training with MuJoCo. But since I have a DGX Spark now, there's a version of MuJoCo you can run on JAX or something called Brax, where it runs on JAX, which is like Google's newer tensor processing library. And it can actually run an insane amount of parallel environments and steps at the same time. So it could run like 8,000 different environments, and it allowed me to run way quicker. So I think this took an hour and 42 minutes basically to do 300 million steps and get to this pretty good walking state. If you're running this on a CPU, it would probably take something like 11 hours or 12 hours. So just noting that if you don't have a powerful GPU and you want to play around with this, check out one of the simpler models just to get started and then move up in the complexity probably. Let's see, I had some other notes in here. MuJoCo stands for multi-joint dynamics with contact. So basically it gives you, if we actually go look at like their intro, their intro here. I don't know why. I think seeing the models move around are just really funny to me. Like even in even in a failed state, like even though you don't have the physical thing, but seeing something like this move around physically, I find is pretty fun and entertaining. So MuJoCo gives you a way of bringing in different environments and models, and they have this kind of XML that gets written out. So this is like the MuJoCo environment, another wrapper. And then in this case, it's creating a box, but you can create different shapes in here, or I believe even import different shapes that you've designed. And then you can render these basically, and you get this model and this data point. Basically, I think the data here is like a state. So with reinforcement learning, because you basically have an object or something that's happening, you usually have a state, which is like the current state of the object, some sort of like step, like you're moving that object, and then like a reset basically for that. And MuJoCo gives that to you for a physics environment. So you can define things like these cubes, you can give them weights, you can give them different joints, and that's how we can do those movements. So this breaks it down. Again, you can go run this collab from this official MuJoCo repo. And it's going to show you kind of how to step-by-step build a model, just a simple shape here, but then add things like joints to it, add things like physics, like how heavy is it in that environment, where can it turn? So again, it adds like a joint here. It's going to turn a different way now. You can add like basically motors and what can those objects do. Let's see, I think they have some other interesting renderings. So this is spinning around. Like you added that it had probably had a lot of force applied to it. A very different shape. So again, joints moving around, and you can get really nice kind of more complex physics going on. Scroll down, they have this. I think they have another one too. So they have these other models, so you can train this, not advanced humanoid. Like you could probably train this without 300 million steps. Get it doing some sort of movement anyway, since it's a little more unrealistic movements, I believe. Unlike the Unitree G1 model is actually like modeled exactly kind of how it works in real life. But now you can build out these physics environments here. Again, with like this is behaving as you would think. It's got gravity. It knocks over these dominoes. It launches this little thing here. And so you can build your own environments here, and then you can bring in models that people have already created. And there's a menagerie here of existing models. I'll share the link to this. So if you actually have like a Spot Mini or something like that, chances are that the robot model someone else has already made it in here that you can start using. So you can see there's some of the Unitrees. Oops, we zoomed in on the wrong screen. It messed up my stream link. Zoom in here. Some of these humanoid ones, like again, you might have actually seen are real ones. Same with the Spot Minis. Some of these other legged ones. So if you have the Boston Dynamic Spot existing in here, I haven't tried like a flying thing. I think that would be interesting. I think there's a couple of drones in here. There's a lot of arms. So if you do have, again, a lot of these are real arms that you can buy too. So you can bring in this model, train it, and then bring that model over to your real life arm, and hopefully it would behave good. There is some drone ones. Like I was saying, I haven't done a drone thing in here yet. I think that would be interesting to try potentially next is like a flying type of object. And an arm one might be cool too. They have hands. And actually don't know what this is. Is this a sensor? So you can also bring in like when you are doing simulations in here, not only can you do motor control. I didn't do this for this one, but I believe you can also bring in sensor data. So like you want your robot to increase the reward, and part of that could be that you have like walls or something like that, and you want it to avoid those walls or do something when it runs into something. So there's different sensor data that you can add into the simulation environment, so that if it sees something with its camera or ultrasonic sensor or something, and then you can adjust the behavior there of like backing up and moving around it. And there's another example where they go through, again, you kind of just import this XML for this humanoid model. So you saw the basic XML here. Oops, sorry, at the top here. Scroll up. Again, this is representing that cube model, but you can imagine that there's a much bigger XML file. Actually, probably if we click into one of these, we would see it. But that just gets imported here because the XML file already exists for that humanoid. And then you can render it in. It'll have the physics, so like where the joints are, how it can move in this environment already defined in the XML. But if you don't already have it, then you can create your own, like we did with a cube. Or again, like I was saying, I think you can render in shapes and then add in physics or like where their joints would be to those shapes. I haven't done that. What I want to actually do eventually is do design my own thing in like a CAD type of model, and then bring it in to the environment, and then train it here, and then also 3D print it with a 3D printer I have at home, and then do the whole simulation to real, including the actual design piece. I haven't done that, and I would love to do that. Has anyone here done that? Has anyone run MuJoCo? Because I know a lot of people RCP'd and or even here live. I'm curious if anyone checked out the project before the stream, or if what you saw now makes you more interested to check it out if you haven't already. Does it look interesting? Let's see if this is the XML. If we just click into one of these. Yeah, so here's the XML that someone's made basically to define like one of those robot pieces. Cool. Somebody said yes a few times because Isaac Sim is too heavy. Oh, cool. Have you tried Isaac Sim? Because next week that's what we're gonna try doing. I haven't really tried it. I know that it can run. I got it like installed on the DGX Spark, but I haven't tried doing a ton with it yet. But yeah, I think it's a more of a heavy simulation. We can actually pull it up real quick too, just so people know what we're talking about. So Isaac Sim is an NVIDIA simulation environment. Again, kind of similar to MuJoCo, but I think, like I was saying, and like someone else was saying, it's more heavy. But I think it can do more. I know they have cool examples somewhere. Maybe I was at GDC. Well, I've gone like almost every year, but I see some really cool examples that they have of like robots walking around in there. I don't know what the sign in is on that page. But yeah, I'm excited to try this out. Yeah, I think they have like also a whole bunch more pre-built tougher environments, like, or more realistic environments. Like there's an example of it like walking up and down kind of like pyramid stairs and stuff like that seems really interesting. But yeah, it seems like maybe more realistic rendering, but again, with that is going to be kind of quite a bit heavier. And somebody said they plan to run MuJoCo after the stream. Somebody said they ran a lot of the examples on Colab. Did you run any cool examples on Colab? And if you want to, you're welcome to join the stream. I can send you an invite link, and you can actually present them if you want. And in response to running on Isaac Sim, I think the same person said a tiny bit. It's hard to render the UI and sim on the DGX. Interesting. So what I was doing, and so what I did here is, so I have this is running in Flyte, which I can share a link to that actually too. Flyte's a open source runtime, like AI orchestration runtime that we maintain. So it adds like durability, scalability for both like training models and agents. Now I've been using it to run everything on my DGX Spark as like a home lab. So this whole UI and stuff is through it. And one thing that I found is cool. Again, I haven't done a lot with Isaac Sim, but getting it running. This is MuJoCo going. But I did make sure that I could run it. So if I look at some older runs here, I wonder if this would help in your use case, because what I do is basically I'm running Isaac Sim and MuJoCo as like a headless environment here, and then I do a rendering of the, in this case, like robot that I got to walk after I train the model. The same with the MuJoCo, because it's this one too. Uses Brax, like I had mentioned, is like a GPU version of MuJoCo that can run an insane amount of parallel environments at the same time. And it couldn't do rendering, I believe, in there at the same time either. You have to then take that trained version of the model, run it in a CPU environment, and then render it back. And what I do is embed this into a report that's in the Flyte UI. So this report could be like any HTML or Markdown file. And this worked pretty good for, again, I only did preliminary testing with Isaac Sim, but it ran here. I remote into it. It runs, I believe, in here headless. I don't see the UI at all. And then I render out what happened here. Because again, if people don't know, if you haven't done reinforcement learning yet, again, you'll get these robots doing some crazy reward hacking. So like the reward curve will be going up, but you always basically need a rendering too to see how it's actually doing. So this is the one that was falling down a little bit ago, but we refreshed the report and it's actually walking pretty good now in 37 minutes. You can see the reward curve is going up. But sometimes, like I mentioned, they'll kind of hack that reward curve and they'll be crawling around, shuffling, throwing their bodies, getting that reward up. But then when you look at the actual rendering, it's not doing what you wanted. So what I like to do is, as it's going, I render in a report. I think I have like I forget how many steps, but basically, 100,000 steps or whatever in this case. I'll render in what the robot's actually doing, so I can eyeball, is it actually improving, or is it going off the rails and doing something crazy? And I was able to do that with Isaac Sim too. It looks a little grainy, something I need to figure out. It doesn't really bother me, it doesn't really matter, but this is it did the headless run and then the render for the Isaac Sim in the report. Oh yeah, and they said, yeah, in another hackathon that they went to, their friend tried rendering Isaac Sim by first doing it headlessly and stuff. So yeah, pretty sure this would work. Yeah, you're right, because it might be really heavy doing Isaac Sim through the UI on the DGX Spark. I could see that. I haven't tried that. I was actually thinking about it because originally I was having some rendering issues here, but I got it to work. But yeah, good to know. I will keep that in mind. I've mostly been using my DGX Spark, just remoting into it. Do you have one? It sounds like you at least have tried working on one. I usually remote into it with Tailscale and then run stuff in Flyte and get the reports here, which is super nice. There was something I was going to bring up here. We already kind of showed the Google example of MuJoCo, but in the README, I do have some logged here. So again, it builds out the body. This isn't the full robot body that we just saw. It's just an example of doing the physics environment. The G1 we loaded in like we saw in this example. It's a pre-existing XML file that we basically read in. Oh, one thing that bit me a little bit a while ago too was when I was transitioning from these kind of built-in MuJoCo models to the realistic ones. There's different types of motors that they can have inside of their models, and the realistic ones, I forget the type, like they have like a stepper type motor or something instead of like a servo. And I did not update that at first, and that was causing a lot of issues too. So just something to think about, which should be obvious, but I didn't do it, is, when you import a model, make sure you look at like what the actual specs are for the movement piece and stuff, because they can be different than a different model if you're taking existing code from it. Let's see. I think we had, I had a table. Oh yeah. So this isn't all of them, but with the reward function for this humanoid robot, and this comes from the pre-built model from DeepMind. So DeepMind owns MuJoCo now. It's open source. Originally it was a different company. I think they bought it and then they open sourced it, which is really cool. But inside of DeepMind's model, they'll tell you these are the things that you might want to do to get that humanoid robot working good. So you can see there's more than just moving forward. There's these different things like feet air time. That's going to get it to lift up its foot, right? Orientation, standing still, feet slip. Like you don't want it to slip, so you give it like a negative reward. So you can see it's penalizing some things and it's rewarding other things. They have this whole list, again, just for your type of model, something you're going to have to think about. One interesting thing too, I forget what it's called. There's a thing in reinforcement learning called, I forget what it is, curriculum learning or something like that. Or basically what it is it layers in rewards. So if you're starting with like a humanoid robot, for example, and it's falling down, the first reward it can learn is standing up. And then once it's learned how to stand up, then you can add in taking steps, for example. And then you can add in raising your knee, moving your feet. So you can add in these kind of layers to your reward policy, which is interesting. But kind of, I already mentioned doing if I go look at the actual numbers, because I upped it from originally when I was doing this. So this is doing the 300 million steps, and it's able to run over 8,000 parallel environments on the GPU. So again, if you just joined in, the CPU version of MuJoCo should work pretty well for a lot of the models. But if you are using or getting something like the G1 to walk, for me, that was taking an insane amount of time on a CPU. And you can look at the GPU MGX version of MuJoCo, and then it uses something called Brax that can do the machine learning with the JAX environment all in one. And actually on a Mac, you can do this too. I'm pretty sure one of my friends did. I didn't test it on my local Mac hardware because I was doing it on the Spark. But you actually, I think you can run Brax on a Mac. So if you have a decent M chip Mac, you actually can probably do this as well. I did not test what it looks like and how many parallel environments you can do on it. Oh yeah, cool. I think it said yes, PME. If you is that to coming up on stream. I don't know if I can private message through LinkedIn, or sorry, through YouTube. Do you want to message me on LinkedIn real quick, and then I can give you the stream link? If that wasn't about joining the stream, remind me what it was. But yeah, people can connect with me there. But if you do want to come on stream, you can also message me there, and then I'll send you an invite link. So if anyone else wants to show off something they built, something they learned, even if it's running through some of their collab with pre-existing models, it's kind of cool to see what other people are building. Oh, they meant pretty much. Got it. There might be somewhat of a shorter stream today if no one else has any other projects to present. But I guess, yeah, any other questions? Not that I'm an expert in everything MuJoCo yet, but any other questions people have? Any other things people want to bring up? Any other tutorials people want to share? Or again, what topics would you want to do next? I definitely want to dive more into, well, I'm going to do Isaac Sim, I guess, next, and then maybe decide which one I want to start using more. And then do, like I was saying, do my CAD design to simulation and then to real. I haven't tried any of the sim to real full loop. If that's what you're talking about. Someone asked, do you think AI can code the XML? I'm pretty sure it could. I haven't tried it because I just use pre-existing models, but you can probably get it to help you build a model. And Niels, for the sim to real, are you talking like me taking a simulation model here and then putting it into a real thing? I haven't done that yet. And then I think Cosmos models have something that is real to sim or something too, where you can actually, I saw a demo once where you take a short video and then I'm sure it takes a while. It'll like render that whole scene and then do physics environment. Like it'll try to guess what the physics are of that environment, which I remember the demo I saw. I think this was at GDC. And that was really crazy. I haven't tried it. I don't know how heavy of a workload that is, but it seemed really kind of crazy to so easily bring in like a real object to the simulation. They're trying to make that really easy, where you can give it reference photos or a reference video, and then it'll try to create a simulation environment around it, which seemed really crazy. I don't know if that's like fully open yet either. Oh yeah, so I haven't done this yet. So I had mentioned before. It was probably before Niels joined, but I do want to do the full SEM to real loop. And if other people want to, that'd be fun. You should come on this journey with me. And I actually want to do the design part too. So I want to do like some sort of CAD program and then design. It'll be simple at first. So it'll be like a simple robot chassis or something that I can add wheels to. And then I want to bring that design into both one of these physics environments like MuJoCo or IsaacSim. And then I also want to 3D print it. And then I'll have gone like from sim to real, but also designing the piece that's the sim and real part, I think would be really fun. Because I'd imagine a lot of times if you're working at a company and you're building your own robot, you're also going to be designing part of it, unless you're taking an existing thing like a G1. But I would want to do that design piece. So I think it'd be really, really fun, like full loop of a thing. I don't know if people are as interested in the actual hardware aspect, but that could be a potential build and learn. I guess like CAD design and 3D printing for sim to real. That could be a week. And somebody asked, do you run on simulated worlds or plan to test on real wait, do you run on simulated worlds or plan to test on real humanoids? I don't know if that's a real question on human testing. I have no plans to do anything with actual humans or oh, you're talking about humanoids, humanoid robots. So I think going back to the sim to real question, I don't have a G1. If I had a Unitrue G1, I would love to take what I just trained it here and then pass it in. I do not have one, so currently I'm just doing it simulation. But then I do want to get to the real thing, just like we had talked about. I just don't know what my hardware is going to be like yet. Someone asked, what's the reward function again? So the reward function was a pre-built one inside of the model, basically from Google DeepMind. So if it's actually, I can't pull it up in my VS Code easily because it's an imported thing in the model. And then I think I adjust 3 parameters in my code here, but it is basically, there's more than this actually. I have to pull up. Actually, we might even be able to go look in the menagerie. The entire reward function, I guess, is going to be in the XML in the menagerie one. But there's a whole bunch of different things like the feet airtime. There's also going to be like forward momentum or like basically movement forward. But I think there's 29, I think it said when I imported it in. I wonder if at the menagerie real quick, let's see if we can find it. Was it I think I had the Unitree G1 and then not sure which one it would be in. I used the MGX one. Let's just see if it's in here. I have to do some sleuthing to find it. It might be a different metadata thing potentially than the actual XML. So I have to look around for it. Oh, so here's the STL files, which is the 3D model. So yeah, as 3D modeling, and then they use the XML to put all those different pieces together and define, I think, which motor kind of specific thing is on there, and probably define weight or something like that in here as well. Yeah, Niels, can you get approval of like, I think you can get a G1 for like 10 grand or something. I think they're cheaper than they used to be. We could get one for the office. That or 2 DGX Sparks. I don't know. And someone corrected after I had corrected humanoid robots, of course, not people. That was my brain just reading that as humans. Yeah, if you have a humanoid robot for me to test on, let me know. Someone said one of those robots costs about 15K. Let's look real quick what current Unitree is. Unitree. I actually don't know what the latest one is. Have you seen the crazier one that they have doing like martial arts? I saw one in person. This one, it's actually kind of scary because it has like some weight to it. I have a video where it like stomps on the ground by somebody and you can like hear it. It's kind of scary. Let's see how much a G1 is. Look, less than 15K now. I'm not sure what the R1 is. Ooh, that looks cool. I haven't seen that one yet. They don't even have a price on it. I don't know if they're selling the H2. Yeah, this one, like I was saying, I saw it in person. And yeah, it has like, it's hard to describe, but there's like weight to it. Like there's never been a humanoid that's kind of scared me before, like, doing moves or anything like that. And this one was kind of scary. Like it would stomp on the ground and you could feel like weight I don't know how much it would actually hurt, but like you could feel like weight on it. And it was interesting. And they had it doing like this fighting and stomping around. It was kind of wild, and it can fall down and get back up. Definitely. I mean, there might be other cool ones now, but these are the coolest ones I've probably seen right now is the Unitree. Yeah, I tried curriculum learning on one of the humanoid things I was doing a while ago about learning to balance first before learning to move. And this tutorial that I'd linked out, like this does just balancing on one of those humanoid models here. So this could be like one first phase of curriculum learning, and then from here you can have it take steps, for example. I was gonna see. I know there was some cool Isaac Sim demos too. Again, this will be next week. So if anyone wants to actually run a project next week and um, run something on Isaac Sim, it'd be really cool. Yeah, so like this isn't a movie here, but they have these cool realistic environments again, so you can train. They always use Unity models. Have them train like walking on. This is like loose rubble, if I remember correctly in the video. So it's like, how do they balance on that? It's different than just like a rough terrain, and then all these kind of stairs going up and down. Oh, and they have an archive paper. I wonder if MuJoCo has a paper. MuJoCo Playground. It's a newer one, so I'm not sure. This might be the old paper in 2012. Oh, have to be a university student. This is before archive really took off, I think. This is a newer one. I'm not sure what paper this is. I'm just going to take a quick look. MuJoCo Playground, a fully open source framework for robot learning built with MGX. So that's the version of this might be the new version of MuJoCo built on JAX that I ended up using. With the express goal of streaming simulation training and sim to real transfer onto robots with pip install Playground. Researchers can train policies in minutes on a single GPU. Yeah, this actually, I think, might be the version that we end up using. I have to see what other environments exist too. Because again, there's probably like a menagerie for environments for interesting stuff. And I guess how to create your own environment. So if I wanted to model like my living room for my robot to move around, that would be the other thing from the sim to real that I would want to do. Niels is talking about how biology solves the problem of curriculum learning with biological development, i.e., babies aren't strong enough to stand up, walk, run, and i.e., learning development happens hand in hand. I wonder if this could be a really dumb idea, but I wonder if there's like a interesting way of curriculum learning for like thought generation or something too, because going back to how babies develop in a representation of the world is probably built up over time. I mean, I guess if you're, I guess if you're like traditional computer vision models, do you have it built up representations in the convolutional layers first? Somebody asks, has anyone tried renting GPUs in cloud to run there? I don't have access to GPU at the moment, so inspired by the session, I'm considering to rent and try my first run. I will just point out, depending on what you're trying to do, I don't know if you can run Isaac Sim in it, but Google Colab still gives you, I think, decent access to some GPU computing hour for free. And then they have like a $10 tier and up. I don't know if you can run Isaac Sim in it. I haven't tried that, but you can run MuJoCo in it. If anyone else has any other providers they have liked to use, feel free to post them. Do you plan on doing MuJoCo, or are you going to run like a whole Isaac Sim environment, or what were you thinking? I think also, so I haven't used it, but doesn't Colab have like a CLI now? Oops, Colab. I haven't tried this out, but it seems interesting. So if you do have Colab Compute, I think you can access it from a terminal now. Seems interesting. Yeah, seems kind of cool. If you want to not just do a notebook, but want to, I think, get access to your basically GPU that you're paying for. You might have to pay for this for the CLI. I'm not sure. Yeah, they have so like Niels brought up, they have a VS Code plugin. I haven't tried it since they first released it. When they first released it, I actually thought it was kind of weird because it was like you can run it. There was something weird about it, where it's like you can run it, but you couldn't give access to local files from it, and you couldn't download anything from it to your local machine very easily. So I didn't really get it at the time why they really made that plugin, unless it was like to start this other work, which now that they have the CLI, you actually might be able to connect and like bring in your local files and then upload them to Colab. But it was kind of weird when they initially released it. It was just running Colab in your VS Code, basically. So if you just wanted it in your VS Code, but you didn't really get, from what I saw, any extra benefits other than you just have your VS Code notebook UI or something like that. But I couldn't see like you couldn't upload it. You couldn't upload files or download files really easily from it. I think I had kind of come up with a workaround where it's like you could get commit and then just get pull from the notebook, and that kind of worked. But it was kind of hacky. But they might have improved it a lot, because now that they came up with the CLI, you might be able to interact with your local files. I'm not sure. I'd imagine so if you're doing it from the CLI. And so they might have added that into the plugin now too. So the plugin, I think, was just like the beginning of stuff they were working on. And when it first came out, I thought it was kind of weird. But not sure if anyone else has tried it recently. Oh yeah, and someone else brought up Kaggle also gives some GPU. Oh, and you may use that GPU time on Colab environment via integration. So that Kaggle is owned by Google now as well. So I actually don't know how they integrate to Colab, but it would make sense that they do. But they used to be more separate. Wonder if there's any current cool competitions going on. Has anyone done a Kaggle competition before that like there's prizes for? I think I've done one of the existing knowledge ones that never ends, but I've never actually done something with like a deadline. This could be fun. Yeah, they always sound fun, but I never have made the time to actually fully do one. If there's no other things that people really want to share, I'll probably wrap up the stream a few minutes early today. Anything else people want to shout out, talk about before we wrap up? If you haven't tried MuJoCo yet, totally recommend it. Like I was saying, you can get started in the Colab environments here. And I know a long time ago, I had tried training some of the other models. Like, again, they have that humanoid model. It doesn't have to be one of the realistic ones. Oops, it doesn't have to be a realistic one, but you can bring in, like, they have a four-legged crawler type of model that's in the MuJoCo environment, like already built in. I guess it's not even in the menagerie here. It's built into the library. And it's really fun to get that like crawler walking and then get their humanoid. They have a like a stick, like a two-legged cheetah type of thing that you can get to run. And then next week, again, we're doing Isaac Sim. And then we're going to move on to the world models. So I'm kind of excited to learn more about the world models. Again, we're going to be going through, let me bring up the schedule again. Dreamer V3 after next week. So next week's Isaac Sim, and then NVIDIA's Cosmos, and then taking a look at JEPA 2, which is open source, and we can check out the paper for that and then actually try running it. I even went ahead and I was trying to, before I scheduled the events, I was like, can I get these running just to make sure? And I did. So they're not doing anything interesting yet, but I did get a dream model running in, I think I use MuJoCo here. See if it, again, like I said, it's not doing anything good. The world model, I think, still has a lot to learn about how to interact with the world. But I thought, again, these models just make me laugh every time during the training phase. So the world model, again, is a way of like predicting state based on actions a little bit differently than like how an LM does tokens. But there's some overlap and similarity sometimes. And the Dreamer 3, like I was saying, is one of the earlier world models that like combines different reinforcement learning things with signals coming in. And what did I do with JEP? I actually forget. I remember I was making sure that it could run in here. And then the Cosmos one, let's see, did I get Cosmos running in here? I think I did. I think this one I actually did basically just a prediction. So this is like a observed model from a frame given, and then it's going to make a prediction of what the next thing is here, which is this like robot picking fruit. But there's a whole bunch in the Cosmos kind of umbrella things. They have a lot in self-driving cars, generating different simulated data based on real world data is kind of a lot of the stuff that the Cosmos models do, I believe. But we'll be taking a look at that. So if you do have a DGX Spark, you can get them all running. If you have other GPUs, you can also probably get them all running too. It doesn't have to be on a Spark, or a lot of stuff can run in Colab or somewhere else as well. So hopefully you'll join in next stream and the streams after. And again, if you want to come and actually come on the stream and present your project, it doesn't have to be super polished. It can just be what you learned, things you ran into. Again, I try to spend at least an hour on the thing, usually, and it ends up being a little bit more. But if you want to come up and talk, that'd be great. And I'll hopefully talk to you all next time. Oh, and I'll shout out the Slack channel again, too, if you want to join there and kind of discuss any of the projects during the week. Totally recommend it as well. Sometimes it's really fun, actually. During the music generation one, we had a fun thread going on there and showing like songs that we were generating. So if you like, hey, I got Isaac Sim up and running, you want to share a clip of it in the Slack group, I'll be there, and quite a few other people are there too. So hopefully I'll talk to some of you there before the next stream. But all right, I'm going to wrap it up.